I think we haven't. Create table with subquery. Adding a column modified, dropping a column. This is all good. Set unused. This we haven't covered. Truncating a table we have covered in detail. Constraints we have covered everything in detail, right? What are constraints, guidelines? Creating views we covered. You wanted to look into this with check option. I will cover it again. Inline views. Okay. Inline views we have covered. Inline views are nothing but when you have a subquery in a from clause. Okay. That's what is an inline view. We have covered this. Okay, other database objects, it is telling about sequence and then indexes. Sequence we have covered, index we will cover. Okay, user access we will cover. Set operators we will cover. Okay, so 11 is half covered, the sequence is covered. Indexes I will discuss. 11, 12 and 14 I actually wanted to discuss today. Group by, okay, this is not done yet. Okay, cube and roll up. Okay, advanced subqueries we have covered this. Okay, 16 is also covered. Hierarchical queries obviously not covered. Then okay, then we will go to PL SQL. In PL SQL we will start with, okay, just a functional PL SQL block. Loop basics, exception handling, very important. These are data types, data retriever cursors, then procedure function and parameters, packages, triggers. Okay. Okay, I believe we have covered around 50% of our whole syllabus, and the rest will be easier to cover because your basics have been done. So actually I had prepared yesterday what needs to be covered. So let me just go through these points that I had prepared, and then I'll come back to the ones which have been missed out. Okay. Okay, Suresh. Okay, be a little louder. I can't hear you. Are you sitting very far from your system? Okay. You can hear me well, right? Okay. I will start then. Okay, so we will start with indexes. Okay. Sequences we have already covered. So we'll start with indexes. What is an index? You understand an index, right? Whenever you buy a book, any book, right? The first few pages are the index pages, right? Where they will say that, okay, this chapter is you can find at page number this point you can find at page number this, and all that. So what is an index? Index is kind of a pointer to the data, right? Index is a sort of assistance in browsing through the book in that case, right? When we are talking about a real world index. Similarly, in Oracle we can create indexes in tables, okay, on the columns, because there we can have there are tables which sort of um, hold records in, tens of thousands, hundreds of thousands, single table with 100,000 records. So that's a large chunk of data. So to parse through, like, think of a very huge book with 700 pages, right? So immediately if you want to find something, what we will do, you will start browsing one page after another. No, you will go and check in the index. Okay, this is what I want to find out, uh, which page it would be in. So you will get it in the index, and then you will uh, check the particular page, right? Clear? Similarly, The same thing we have in Oracle database, which is called here also it is called an index. Index is a database object. Its basic purpose is to help the related SQL queries perform better. I'll tell you how it performs. Okay. So say this customers table had like 100,000 records, right? So when I say select star from customers, this is like opening the whole book one after another, right? Right? We will go. Our human brain is functioned in a way that we will first see the first record, then go to the next record, and so on, right? But we use, if we have to find out something, we use say a where clause in and a filter condition, right? Customer ID equals to 1. Yes, this. So basically, Oracle, when I said creates indexes, it creates indexes on the columns of the table, right? Now, please don't confuse index and constraint. Those are two different things. Okay, I'll tell you why. Constraint, you are very clear, right? Because as I go about explaining index, it might sound very similar to constraint. That's why I said you're clear about constraints, unique constraints, not null constraints, primary key, foreign key, check constraints, all these things. Okay. So coming back to indexes, points are its basic purpose is to help the related SQL queries perform better. An index is a performance tuning method of allowing faster retrieval of records. An index creates an entry for each value that appears in the indexed columns. Okay. So what the index does is, say okay, this is the create index syntax. Say we create index uh, some okay, customers IDX on. This is how you create an index. Customer. So you create index keyword, then you give your index name, then keyword on, then the table, and then within brackets the column. Right? Clear? Very simple. Yeah. So and this can be one column or a combination of more than one columns. Okay. Say we have index on customer name. So what it will do is once this index is created, what it will do is for every entry in the customers table, okay, as and when the entries are increasing in the customers table, for every entry, every new entry which is there in the customers table, the index will implicitly create an entry within itself. Okay, you will not be able to query the index. You can't see what sort of a pointer to the data index is storing, right? But it will sort within itself. It will sort the data of the table based on the column. Is it clear, or you want me to repeat? Not getting. Okay. So this is how you create an index. Okay. So you see the customers table. These are the columns: customer ID, customer name, contact name, address, city, postal code, and country, right? So basically, okay, I'll get to that later. Which column should we choose to create an index on? I mean, basically, it is the more unique the data, the better the index will function. But let's first understand how an index works. Now, I run this statement. Okay, if I run this statement, it creates an index custom, which index name is customers underscore idx, on the customer id column of this particular table, of customers table. That's how you okay, not customer name, it's customer id, customer id. Okay, now next time when I, how you can get to know? Okay, the index will exist as a separate object, and when you check it in the table, once I get the Oracle installed, right, before we go into PLSQL, I'll show you. I mean, in the database, in the list of tables, you right click on any given table and it will show you what constraints are there, what indexes are there, and all that. Okay, so if your index is created, it will get, I mean, successfully created, it will get successfully attached or associated with the table. Okay, try to understand the concept. Don't think too much about how it will show and how it will how I can access it. That is not very important. That's even a standard 5 child can also understand that. Okay, what is more important is understand the concept, why we use an index and how does the index help. Okay, so creating this, okay, what I was doing, okay, I created a index on the column of customer ID. I can't hear you. Yes, that's what I'm explaining. Okay, listen. Now, after I create this index, then I run this query. Okay, so what it'll do is, now customer ID column has an index customers underscore IDX on top of it, right? So say this customer table had hundreds of thousands of records, right? And I needed only data for customer ID equals to 1000. Just give me a moment. Okay, and the customer table was a large table with a lot of data, and we need a particular customer ID. Okay, now with the with the existence of an index, now how this query will function is, this query, before going into the customer table, okay, before fetching the data from the customer table, it will first access the index customers underscore idx. This query, how will it will work now? This will first look into the index. Just as I mentioned, in a book, in a large book, if you want to find something, you go and check in the index which page it is in, right? Similarly, this query will now, since it's a large table, this query will now check the index for customer ID equals to 1000. Okay, sorry, I mean, you have to be very loud. I seriously can't hear you. Yeah, but can it be a little louder? Yeah, it is fine now. I could hear my own voice. Were you on speaker or something? Okay, this is better. Leave it this way. Okay. Yes, yes. So any select query you write, I mean, you want to execute, right? So you want the performance to be good. If you execute a select query and it takes 15 minutes to get you the data, it's of no use. It's useless. Okay. So so there are ways of making a select query work better. So those are called performance tuning methods, Oracle performance tuning method. So the number one performance tuning method is use of indexes. Okay, so you have now, okay, like in the index, can't hear you, can't hear you, can't hear you. Yeah, yeah, yeah. Please, I mean, Suresh, please don't interrupt. I mean, let me just finish the whole concept. Then you ask questions, right? The same thing I'm trying to tell you three times now. Okay. When I ask you if you have any doubts, you can please try and pay attention and listen to what I'm saying. I understand your questions are very relevant and very good, but you have to first let me finish, right? Okay. So you understand the create index now and how uh, once the index is created, how a select query works, right? The only missing link is how does the index help, right? How the index helps is like in a book, what is there in the index page? There is an entry for every chapter or every point, right, with the page number. Similarly, here, this index customers underscore idx will implicitly have an entry for all the customer IDs. Okay, separate entry for all the customer IDs. You cannot, I mean, Oracle does that implicitly. It has its own logic and it has its own code of doing it. We as Oracle users, we cannot access that or we cannot check that, right? So that's so when this query is next time run, so before going to the so the so how Oracle works is it'll not start from okay it'll not start checking from customer ID from the first row. Okay, this is customer ID 1, go to the next row, customer ID 3, go to the next row, and then till 1000 it will not do that. What it will do is it'll go, I mean, Oracle will check the index and find out the entry for customer ID 1000, and then it will go to the table to the customer ID 1000 and print you the data. Is it clear now? If you have any doubt, you can ask. Okay, it's the same thing for, I mean, people waste a lot of time in understanding indexes. It's just the same thing as you would use in a book. Just if you understand how you use an index in a book, an Oracle index on a column of a table works the very same way. Okay, and index is a database object. Its basic purpose is this. Mhm. For a You don't create index on records, you create index on columns. Okay, and one column, yes, you can have a combination of columns as an index. So uh, if that is your question, right? And you can have multiple indexes on a table. It doesn't have to be only one index on a table. There can be multiple indexes on a table. Okay. I think there is a limit to that. Maybe 9 or 10 is the limit for creating how many indexes you can create on a table. Because after that, it becomes very. I mean, the performance will get hampered after that because too many indexes will not help you. Okay, too many pointers to the data. It will search in one index, then it will go into another index. Then again, the whole purpose is not served. Right? It is defeated. We want our indexes to help us point to the data faster. We don't want to complicate the thing by creating too many indexes. Okay. Okay. So as I said, indexes are of three types. Uh, Sorry, indexes are database objects. Now there are three types of indexes. One is a B tree, which is binary tree index. One is a bitmapped. Okay, this is also called as hash index. and then there is a function based index. So differences is, now what I just uh, told you, right, about index and the most and the default, this is the default index. Default index is a binary tree index. Okay, whenever you create a index, Oracle will by default create a binary tree index, and this is useful in case of data in the column being relatively unique. It doesn't have to be okay. You here in this table, only customer ID it seems has unique data, right? But it doesn't have to be that your index will have to be created only on the customer ID. You can create an index on customer name also, right? It might not be unique, but still you can create an index on customer name also. Okay. So in this case, in customer names are also fairly relatively unique, right? You cannot find too many people with the same name. Uh, I mean, you are likely not to. So names are also fairly unique. But and whatever I just discussed with you, it's sort of why it is called a tree, because it sort of holds the inherent or implicit data in in the form of a tree. There is a tree structure. I mean, you can find that in some sort of documentation. You don't need to go too much into that. See, these are the basic SQL concepts. You don't want to go too much deep into how a binary tree saves data. Not needed, right? Just remember this much. Yes, that's what I'm telling you. See, you don't need to know too much about binary tree. Okay, you must have seen a tree, right? What are there in it? What are the different parts of a tree? There are branches, then there are leaves, right? So you would have. If Are you talking to someone else or you talking to me? I can't hear you really. Okay, but I can't hear you. So fine. So in a tree, what is the smallest unit in a tree? It's kind of like a leaf, right? It's a huge kind of mango tree or whatever. A leaf is the smallest unit. So a binary tree index holds each, like here we created this index, right? So for each record it will have a entry inside the index, right? For each record it will hold a, separate or unique entry. So it is like for each record, uh, for like in a tree, in a natural tree, binary tree will have a single leaf. On its leaf node it will have one record. Understood? So it's a tree structure, it's a unique tree structure. Okay, that means one leaf is always unique, right? In a tree, a leaf is separated from everything else, right? It's a unique structure. So if I know, okay, you're going to a mango tree and you can you know exactly which leaf the mango is adjacent to, you will go and go to exactly the particular leaf, right? You will not start searching from left to the right of the tree and then find out, locate somewhere the mango is, and then go. Understood? So I mean, simple thing. If the data is unique, when we create an index, we create an index mostly after the table is already populated with some data. Okay, it's not like constraint. Constraint is when so for constraint is we are putting a restriction while creating the table itself, that customer ID always has to be unique, right? But when we create an index, we already have seen some data, okay, fine. Mostly customer, in this call, in this table, customer ID seems to be a column which will always hold the unique data, or say customer ID is the primary key, so we know that it will always hold the unique data, so we create an index on customer ID. So that way the table is sorted faster or easier, in an easier way, when we run a select query on the table. Understood? Now this index is of three types. First is B tree, that is binary tree, where each record is held on a separate leaf node. Okay, I think this will be a good way of, each individual record is held on a separate leaf node of the index. Clear? This is a good statement. Understood, understandable, right? Okay. But then there is a bitmapped index. Now this is a weird index. Why? Because this is used in case of columns where um, data is not unique. For example, there is a population table. Okay, just listen to it. There is a population table. There is a city population table. Like for Pune, these are the population records, right? And there is a gender column, right? In any population, in any census, you will have a gender column, male or female. Now, there is a requirement to put an index on the gender column. Say there are 20 lakh people in the city, and for every person there is a record in that table, and for every person there is a entry in the gender column, so it will either be M or it will be F, right? So there will be 10 lakh M, around 10 lakh M records and 10 lakh F records. So the data is hardly unique, right? It is the exact opposite of unique. It is highly repetitive. But still, if you want an index on it, this is the this is how Oracle creates an index. In that case, the B tree index won't work. So Oracle creates a bitmapped index, which is kind of like a hash index or a heap index. Not hash, it's a heap index. So it's sorry. Look into the same table. Okay, customers table. Sorry, Suresh, I have to go fast. We can't do this for months, right? I have to finish in 1 month. See, these are concepts. You, if you want to complete one chapter in one session, I have been incredibly slow from the beginning, right? I have, because the beginning is very important. I have been incredibly slow from the beginning, and I have to started with concepts which are not there in the syllabus. You please try to understand. Okay, this is nothing. You are quite intelligent, and this is nothing rocket science that I'm saying. And I'm telling, and I'm explaining it to you in a very, very, you know, simple way. You understood B tree? You understood B tree? Okay. So bitmap, you are not able to understand, right? Fine. I'll give you the example from this particular table itself. So here it is holding 90 records. Imagine that it holds 100,000 records. Okay, but customer ID will always be unique, but country will not be unique, right? Say it holds data from only four countries: Germany, Mexico, UK, and Sweden. Okay, so the for the 100,000 records, it is either one of these four values in the country column. It is either Germany, either Mexico, either UK, or Sweden. So the uniqueness, you understand the term uniqueness? uniqueness, or it is also known as cardinality. Okay, so the uniqueness of data in the column country is very low, right? The data is hardly unique, right? It is highly repetitive. But there is a query like this. There is a query like this, right? So here we are not accessing customer ID. What are we having in our filter? We are having country. So even if we have a index created on customer ID, it will not help here. You understand this? Index will only be accessed when it is used in a where clause. Okay. Basically, what the index does is it sorts the data and holds it. But if you don't access it in a where clause of your select query, you will not get the benefit of the index, right? So in this query, although we have a index on customer ID, customer name, we are not accessing these columns in our where clause. So this index will not be called. Okay. So if we know that such we will have to do we'll have to perform such queries very repeatedly, uh, and we sort of everyone in the team decides that okay, we are going to have a index on the column country also, right? We are going to create an index on the country column also. But we already know that the country column can have only one of the four values for 100,000 columns. Sorry, 100,000 rows. And you know, you never know how many 100,000 will be added in future, right? So it's a large table, and this column can only hold one of the four values. So the data is not unique. Data is highly repetitive. So in that case, it will not be creating a B tree index. Oracle will not create its default B tree index. It will create a bit mapped index. Okay, what is a bit mapped index? Bit mapped index is kind of like buckets. Okay, okay, like I gave you an example of a tree on which every leaf will have a pointer to a separate data. Similarly, there'll be so for this there'll be four heaps or four buckets. There will be one Germany bucket, one Mexico bucket, one UK bucket, one Sweden bucket, and all the data of Germany, all the records who have country type, country value equals Germany will go into the Germany bucket. Similarly, Mexico bucket, UK bucket, Sweden bucket. Is it understandable now? Okay, so when you run this query, it is at least a little bit better, because instead of searching the whole table, it will at least go to the relevant bucket. So it will go to the Germany bucket. It will not go to Mexico, Sweden, or UK bucket. Understood? So that way it will be at least what, four times faster. Correct? Simple, or was it difficult to understand? Okay. So that is one more type of index. This is used in case of columns where data is not unique. Remember this, you will hardly ever use it, but they will ask this to you in interviews. Okay. Example I can give. Example is population, sorry, gender column in population table or city column in customers table. Next, the third type of index is function based index. Now, what is this? This is the same as B tree index, but then we, while creating the index, we use one of the functions on the column name. Simple. Same we were doing, create index supplier IDX on supplier, just supplier name. No, we will use a function on it. Okay. So why do we use this? Sorry. No, 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 no. Not data modification. Index doesn't modify your data. Index only sorts the existing data. See, whatever we are creating index, it is based on what kind of query we are most likely to write. Okay, what kind of query we are most likely to execute. We know that on this table we are going to execute this kind of query every day. So we create a bitmap index. We know that we are going to upper of customer name like Alfred. Okay. If this is the kind of query that we are going to execute more frequently on this particular table, we better have an index like this, upper of on simple. See, the basic purpose and the only purpose of an index is to make our SQL queries run in a better way. It doesn't, uh, the index doesn't, touch the structure of the table. Index doesn't manipulate, or index doesn't do any kind of restructuring in the table data. Index is a separate object. It is associated with a particular column in a table, but it is a separate object. Okay, clear? So, yeah, so these are the three basic types of indexes, and various functions, various statements that you can do for an indexes. You can create an index, you can alter an index, you can drop an index. These are all DDL statements you can do on an index. By altering an index, you can either rename it, you can drop the index completely also. Okay, these are the various um, DDLs you can do with an index. So that's all is there about index. Any doubt? I mean, we just completed it. Anything fresh on your mind? Any doubts on indexes? No. Okay. Next is user access management, right? So when you uh, getting a call, sorry. Couple of minutes, huh, Suresh? Couple of minutes. implement user access or access management, right? When you access Oracle, you access it as a user. Okay, so you access it as a user, right? Okay. Or I mean any kind of login scenario, like you have a email, right? You access it with your login and password, login ID and password. So that login ID is nothing but your user ID. It's also called user ID, right? Your bank account and all, you call it user IDs, user ID and password. So similar thing Oracle has. So that's how you can create an user. Okay, now before all this create user, all these things only a DBA can do, not uh, only an administrator can do. If you just logged in and you were given access by someone else, you cannot create an user. We'll get to that. Just let's go one by one. Okay, this is the command for create user. We can create an user. Identified by is the password value, default table space, temporary table space, quota, password expire. Now your first question will be, what is a table space, right? Do you know what a table space is? Okay, table space is, so it sounds very similar to table, right? But it is different. It is not the same as table. I'll have a footnote here. I should have written it. What difference between table and table space? Table is a logical structure to display data in the form of rows and columns. Table is a database object, right? This is simple. Table is a logical structure to display data in the form of rows and columns, and table is a database object. But what is table space? Table space is a physical part, public segment of the storage space, okay, on the database server. Table space is a physical part oblique segment of the storage space on a database server. So in the first initial classes, I explained, right, physically how data is stored, and logically physical and logical, you remember? So physically data is still stored in disks. It occupies some MB data, some GB data, some TB data, some KB data. So it is stored in bits and bytes, right? So table space is one of the units of that. Uh, so say your database server uh, is a single setup. It will have say 100 table spaces. Okay, so and each table space will have a name. We don't have to worry about how do we create a table space and how we want to manage a table space, because that is all DBA role responsibilities. That is not what developers are supposed to do. Okay, just you understand that table space is a physical segmentation of the database server storage. Okay, so basically, and another thing, whenever we are creating a table, right, logically we see that the table is created and it is holding rows, so physically also it goes and stores into a table space. So by default there is a table space which absorbs the data of the table. Okay, so basically it is the default table space. So for every Oracle database there will be a default table space specified. So generally that is what is associated with the user. So there is a default table space, there is a temporary table space. There is a concept of temporary table space also, because there is, we will get to know in the future that there are things called temporary tables which are created sometimes, or temporary objects which are which only persist till the session. Okay, your session ends and the object disappears. It is not stored in the permanent table space, or it is not stored permanently in the database. You create something, a temporary table, for the benefit of your current session only. Okay, that those objects reside in the temporary table space, so you have to assign both of them. Quota is how much space you can take up. Okay, as the user, how much space the user is allocated or can, what is the limit. Password expire means after the first login, so you have this in many things, right, in your single sign-ons. After the first login, you have to create your own password, right? Understood, right? Yeah. So password expire means this is optional. You can have this or you can not have this. So if you want your password to remain the same, if you want the user's password to remain the same forever, you don't have this, no issues. Okay. Now you have created the user. What next? Okay. So try to imagine this scenario. You are a DBA. Okay. There is a new employee who has joined your company. Now you have to make him give him access or give him login privileges, login roles to your database. So this is how you go about it. First you create the user, then you grant privileges to the user. What is privilege? All these things, right? These are called privileges. Say on a table, what can I do? Everyone is not supposed to access everything on a table, right? So I can only perform select queries on a table. Select is a privilege. I can only perform inserts, update, delete in a table. These are DML privileges. Insert, update, delete. I mean, select is the most basic, then insert, update, delete, references, then alter, index. Just we discussed index, right? So you have to have the create index privilege. So these are the privileges that exist on a table. So the DBA can choose to give you any single or any combination of these privileges depending on what you're supposed to do. You're not supposed to create, you're not supposed to do any data modification. Then the DBA will not give you insert, update, delete privileges. Okay, you are only supposed to create I mean have select queries. You're only supposed to read the data from the table. Then the DBA will only give you select privileges. Okay, so privilege means on a table means these are the table privileges. So the DBA can choose to give whichever privilege he wants to give to the user he just created, right? This is the username. So syntax is grant privileges on object to user. So grant, say, all on suppliers to Suresh. Now suppliers is the object that is table here. User is Suresh. All means if he wishes to give everything, that becomes all, right? All the privileges. You can do anything with the table. That becomes all. But if he only wants you to be able to read the data but not do any modification, then this is how he will ensure that. So if Suresh is given only select privileges on the table suppliers, he cannot insert any data to the into the table. Simple. Similarly, yeah, this is a this is privileges on a table. Similarly, we have privileges on functions and procedures, which is nothing but execute privileges. Okay, function procedures we will learn about it in PLSQL. Uh, so just remember that someone has to grant you execute privileges so that you can execute the function or procedure. Even if you want, even if you see it in your list of objects, you can't execute the function or procedure if you don't have the correct privileges. If the DBA can grant privileges, the DBA can also revoke privileges. Okay, the syntax is here. Revoke privileges on function and procedure also it can do. So nothing much here. And these are not activities that you are going to do. You can do it when you are the um, when you log in as sysadmin or something like that. You can do it. Okay, but in the real world scenario, you are not supposed to do all this. This is DBA's role. Okay. Then what is role? Now a role is a collection of one or more privileges bundled together. A user can be assigned a role, and then the user will automatically get the privileges. Okay, now what is a role? A role is a collection of one or more privileges. For example, create role, test role, identified by test 123. Whenever you see identified by, it is just the password. Okay, grant privileges on object to role name, grant role name to user. Okay, so this is the sequence. I'll just have example: create role, um, new user, identified by test 123. Fine. So the DBA creates a new user. Just imagine the scenario. I just told you, right? You have joined new. Just imagine that 1,000 new executives or new people have joined in the company. So the DBA can either be stupid and grant privileges one by one to the 1,000 users, or the what he can do is he can be smart and he can create a role which has bundled up all the privileges that you need in all these users need, and assign that role to all these users. Is it clear what I just said? Okay, so which one is smarter? I mean, writing 1,000 grant statements is far smarter, or writing one grant statement is smarter? Writing one grant statement, right? So create role new user identified by this. Say all the new users are only supposed to have read privileges, that is select privileges on a particular table. So grant select on customers, or what it was, whatever, suppliers who, now here he is granting the privilege to the role that he has just created. Okay, not to an individual user. And then he will grant, no, new user is not a collection, new user is a role. Okay, new user will only contain the privileges. Okay, now he will grant this role to how many ever users he wants to. Okay, user 1, user 2, user 3, user 4, user 5, all these things. Role means a collection of privileges. Which, okay, let's just, this is very simple. I'll do it again. Okay, you understand privileges? Privilege are nothing but what rights you have, right? There is a table as a what is the user supposed to have and what he is not, I mean what he is restricted from having. For example, there is a user who is only supposed to read the data from a table. He can't do any insert, update, delete. He cannot do any DML. So he will get only select privilege. Now you understand privilege. Now go to role. Now a role is nothing but a statement where you will have a collection of privileges, not a collection of users, a collection of privileges. Okay, like here what we did, we created a role, we granted we granted select privilege to the role. we, New user is not a user, it is a role, right? New users, let's see, so that will be easier for you to understand. So here we are granting privilege to the role, and then we are granting this role to users. Okay, so this is useful in case of multiple users, if you have to onboard at the same time. Otherwise what you had to do, otherwise you had to do um, grant select on suppliers to 1, then grant select on suppliers to 2, 3, 4, 5 till 1000 you have to write. But that's just, yeah, you got it right. Yeah, so this is what is. And as a bonus, you understood what is difference between table and table space, right? I know it is, you cannot understand it in one setting. It will take some time, and I mean, you have to realize one thing, Suresh. I mean, someone teaching you Oracle, you can understand, and I can teach you the basics. If I go too much into the advanced concepts, it'll not make any sense to you. Okay, when once you start working in it bit by bit, you will understand, but your basics should be very strong. So what I'm trying to do is here is strengthening your basics, that's all. Okay, so I'm currently going to share this document with you. So these 4 or 5 points we will start from in tomorrow's class. Okay, and then we will go to a very simple couple of very simple things. Mm, I think there was some set operator. This is a child's play. This thing is very simple. It will not take more than 10 minutes. It's very simple. Okay. And we will try to we'll try to complete 15 also. 15 is a little complicated. It will be a little difficult. Okay. We don't need to, because all these things we have already dealt with. You can check. You have this document with you, right? Sequences. Okay. Sequences we have already discussed, right? You want to discuss it again? You can just go back to your notes. Okay. It's the same thing. Next val, curval, I had discussed while creating a with surrogate key example. I had given you all the concept of the sequence, right? Yeah. So next we will do set top 14 and 15. Let's try to complete it. 14 I know is very simple. It will be completed in 10 minutes. 15 might take a little time, but before that, before going to 14, I will try to complete all